Hello and welcome to the Statistics for Data Science lecture series. This is a beginner friendly course. So if you have no exposure or you have not done any statistics before, do not worry. We'll go through right from the very basics, right? So let's start the video. So we'll look at the location estimators first. So first, what we have is mean. So mean is the sum of all values divided by the number of values. So I'll give you an example. So for example, if we have suppose few numbers like 2, 5, 7, 9 and 11, say these are our numbers. So what I mean, how we are supposed to find the mean is we have to add all of these numbers, all of these values. So we first find the sum. So 2 plus 5 plus 7 plus 9 plus 11, right? So that is 2 plus 5 is 7 plus 7 is 14 and 9 plus 11 is 20. So 14 plus 20 and that will be 34, right? So now the number of values is we have 5 values in our data set, if you call it. So number of terms or number of values is equal to 5. Therefore the mean will be equal to 34 upon 5. So this will give us around 5 6 are 30, so 6.8. So this is our mean. That is how we find the mean of a given set of values. Next we have something called as weighted mean. So the weighted mean is defined as the sum of all values times the weight divided by the sum of the weights. Okay, let's look at an example and try to understand this. So suppose I have these values xi, say, and the frequency of or the weight to each of these values is given. Suppose 2, 3, 5 and 7, for example, and the weights given are 10, 15, 11 and 4. Okay, these are the weights. So so what we can do is we can see, as you can see, that the highest weight given to a value is 3, right? It has the highest weight, means this will impact our mean the most. Okay, so to find the weighted mean, what we do is we multiply them. Okay, so it will be 2 into 20 plus 3 into 15 plus 5 into 11 plus 7 into 4. Okay, and then what we do is we divide by the sum of the weight. So the summation weight will be equal to, how much is it? It is 10 plus 15 is 25. 25 plus 11 is 36 plus 4 is 40. So divide by 40. So this will give us how much? 20 plus 15 to the 45 plus 55 plus and 4 the 28 divide by 40. So if we add this, how much will we get? We get 148 and then divide by 40. So this will give us 3.7. See, so as you can see that our mean is closer to this value because and it is expected also because this is given the highest weight. Okay, so few advantages of using a weighted mean. We can see I have written 2 points, so let us look at what they are. So if we are looking, or if we are taking the average from multiple sensors and one of these sensors is less accurate, okay, suppose there's a field project and there are sensors from which data is been collected. So if one of the sensor has a lesser accuracy, then we can like downweight the data from that sensor. So this way we can minimize the error from that particular sensor. We may not have a data set that accurately reflects all groups. We can give a higher weight to the values from the groups that were underrepresented. So if something is underrepresented or it is like having lesser numbers, we can give it a higher weight to bring it to the same platform as the rest. So next what we have is median. So by median, what do we understand? the value such that one half of the data lies above and below. So when we talk about medium, we are essentially speaking about the middle term in a sorted list of data. So this is very important. The data needs to be sorted. So for example, if we have something like 2 7 3 1 9, so if we have something like this, so we have to arrange this in an order. Okay, it can be ascending or descending, doesn't matter. So if we arrange this data in ascending order, for example, say, so the ascending order would look like 1 2 3 7 and 9. Now uh, we can see that here that 3 is the middle term, because uh, to the left of 3 we have equal number of digits or data, and to the right of 3 we have equal number of data. So 3 becomes our middle element. So there is also a formula to find the median value. So if your number of elements, for example in this case we have n equals to 5, which is an odd number. So what we do is to find the element which is the central, or to find this middle element, what we do is we use this formula n plus 1 divided by 2. So we have 5 plus 1 divided by 2, that is 6 by 2 is 3. So do not confuse the value. This is not the value, this gives us the position. Okay, third position. So in this case our value and the position number are same, so this our third position becomes our median value, right? And if you have suppose you have let me erase this to make up for some space. So suppose you have 2 7 11 4 3 5, something like this. Okay, so again we have to arrange this in an ascending order or a descending order, it depends upon you. So if we arrange this in ascending order, we have 2 3 4 5 7 and 11, right? So now what we have to do is we have to check the number of values. So in this case our number of values is 1 2 3 4 1 2 3 4 5 6 6, which is an even number, right? So what we have to do is we have to take the n by 2 and n by 2 plus 1, these two terms. Okay, and then find the average of these two terms. So what is n by 2? It will 6 by 2, so this is 6 by 2, basically 3. So the third term, and the n by 2 against 3, it will be 6 by 2 plus 1. So this is like 3 plus 1, so equals to fourth term, right? So the fourth term would be this. So we have to take the average of 4 and 5. So this is 4.5. So 4.5 becomes our median value. Next we have weighted median. So by definition, the value such that one half of the sum of the weights lies above and below the sorted data. That is, the sum of the weights is equal for the lower and upper halves of the sorted list. Okay, so suppose in this figure we can see that, suppose this is having, these are all uniform shape. So suppose this is 2 2 2 and 2, again this is 2 2 2 and 2. So you can see that this is our median, weighted median. So you can see this part, if you add the weights to the left hand side, then we are getting 8. I'm just taking a random value 2, but these are uniform. You can also take x if you want, x being a variable. So x x x x x x x x. So you can see that the weight, sum of weight to the left hand side of the weighted median is equal to this will equal to 4x, and similarly this will equal to 4x, right? So similarly if you add this part up, so this, then this, so if you add, this is x, y and z, Okay, and suppose these are I, J, K, L, M. So we can say that x plus y plus z will be equal to I plus j plus k plus L plus M. Okay, so the next topic that we'll discuss is trimmed mean. So trimmed mean is defined as the average of all values after dropping a fixed number of extreme values. Trimmed mean eliminates the influence of extreme values. So suppose you have 2, 3, 5, 7, 8, 11, and then suppose you have a big number like a 200. Okay. So because of this 200, our average will look very different. Okay. So what we do is, in case of trimmed mean, we try to remove this 200 and then take our mean, because otherwise if we include 200, our result will be skewed. We won't be getting a very accurate result. Okay, because most of our data is having smaller values, and certainly this extreme large value will impact the overall average. Okay, so what we do is we try to remove 200 and then take the mean. Next is robust. So this is a term which means anything where you see that a parameter is robust if it is not sensitive to extreme values. For example, as we have seen that median, okay, then trimmed mean, these are all robust in nature. Okay, so that is what this term means. And finally we have outlier. So a data value that is very different from most of the data is called an outlier. So the median is referred to as a robust estimate of location, since it is not influenced by extreme cases that could skew the results. We have already discussed this. And yeah, so outliers are basically extreme values only. So these are terms which are used in statistics. So if you are going through some article and if you do not understand what outlier is, it might be confusing. So it's better to know what these terms mean, so that you have a better understanding when you go through some statistics related post or an article. Okay, so I think this is it for this location estimators. In the next video, we are going to discuss estimators of variability. So we'll discuss topics like range, standard deviation, variance, etc. Okay. So if you found this video helpful, please like this video and share it with your friends. And if you like the content in my channel, do subscribe to my channel and hit that bell icon to never miss an upload. Thank you so much for sticking by, and I hope to see you guys very soon.